Okay, we're on Module 4, Lesson 3, Modeling with Arithmetic Sequences, and we're going to just kind of continue in and start problem solving using these sequences. It's sort of a continuation of everything that we've already done. Okay, you can model real-world situations and solve problems using models of arithmetic sequences. For example, suppose watermelons cost $6.50 each at a local market. The cost in dollars of n watermelons can be found using C of n is equal to 6.5 n. So the cost that you're going to pay is a function of how many watermelons you buy. So your watermelons, 1, 2, 3, 4, total cost, and there are your numbers, your terms for that sequence. The common difference is $6.50. Okay. What does n represent in this context? It represents the number of watermelons that you're purchasing. What are the dependent and independent variables in this context? Well, I know that the cost that I pay, or, the bill that I pay, or how much it costs, depends on the number of watermelons that I purchase. So my independent is the number of watermelons, the dependent is the cost, because my cost depends on the number of watermelons that I buy. Okay. And then it says to find C of 7, the value of the function when you are purchasing 7 watermelons. So this value represents the cost of buying 7 watermelons. I put in 7 for the n value. And if I did my math correctly, that should be $45.50. Okay. And then it asks what domain values would make sense for this situation. Well, I'm going to use 1, 2, 3, and 4. If we were to go beyond what's in the table, then any whole number would make sense. I mean, you could buy 10 watermelons. But we're not going to buy in this situation like a part of a watermelon, so we need to stick to whole numbers. So you don't necessarily need to write this down, but I would like you guys to start making the connection between the explicit rule that we keep writing and a function that we've been talking about. So if we go back to the watermelon example, f of 1 is equal to 650. The common difference is also 650. If I put it into the general explicit rule, then it comes out like this. If I use the distributive property, that becomes 6.5n minus 650. And if you notice, these two will cancel each other out, and you're back to what they gave you for the function at the beginning. Okay, so just understand that the explicit rule and the situation written in function notation, they might be disguised a little bit, but they're the same thing. All right, I'm now on the following page where it asks to construct an explicit rule in function notation for the arithmetic sequence represented in the table. Then interpret the meaning of a specific term of the sequence in a given context, or in the given context. All right, so when I look, I've got number of ounces and then the cost of postage. So we're talking about how much it's going to cost to post a letter. And they want you to determine the value of f of 9. So, for instance, how much is it going to cost for you to post a 9-ounce letter? First, you need to find the common difference. If I go from here to here, that's 20 cents. From here to here, that's 20 cents. From here to here, that's 20 cents. So the common difference is 20 cents. 0.35 or 35 cents is the value for f of 1, and you just put it into the explicit rule, okay, and you get f of n is equal to 0.35 plus 0.20, and then in parentheses n minus 1. So f of 9 is going to be equal to 35 cents plus 0.2 n minus 1, 9 minus 1, which is 8. And when you do all that math, you get $1.95. Okay, next example. This table shows the cumulative total interest paid in dollars on a loan after each month. So number of months, cumulative total interest paid, and I notice that each time I go from one term to the next in the sequence, I'm increasing by 70. So it says to determine the value of f of 20 and tell what it represents in this particular situation. Okay, so first step was to find common difference. I kind of already mentally did that. 230 minus 160 is 70. 300 minus 230 is 70, etc. So the common difference is 70. And then I'm going to substitute 160 for f of 1, because it's right there. And I'm going to substitute 70 for my common difference, d. And just put it in the formula. Okay. So f of 1 is 160 plus 70 times n minus 1. Okay, so find f of 20 and interpret the value in context. Well, so f of 20 is going to be equal to f of 1 plus common difference times 20 minus 1. And when you do all of that math, you come up with $1,490. What does that mean? Well, it means that the cumulative total interest paid after 20 months is $1,490. All right, so the next one kind of amuses me because I don't know what sort of thing she's driving or whatnot, but she's 56 miles from wherever she started in 4 minutes. So that's pretty lickety-split. I'm sort of wondering if she took off in a spaceship or something. But anyhow, we'll go ahead and do the problem. Construct an explicit rule in function notation for the arithmetic sequence represented in the table, then interpret the meaning of a specific term of the sequence in the given context. Okay, so the table shows f of n, which is the distance in miles from the store after Mila has traveled for n minutes. Determine the value of f of 10 and tell what it represents in this situation. Okay, so first, my f of 1 value is 20. My common difference is d, and that is equal to 12. So I'm going to take those things and put them into the format for the explicit rule. There's what I get. And then I'm going to determine the value when n is 10. So I just simply put 10 in for n and do some number chugging. And after 10 minutes, she's 128 miles away. Like, that's honestly the answer in the book and everything, and that's what I got. But yeah, I'm kind of wondering if she took off in a spaceship or something. Okay, but the process is the same, and you're still using the explicit rule just like we've been.